Hello everybody, Mr. Hasty here. Today we're going to be talking about the behavior of waves, and we're actually going to split this content up into two different videos. Today we're going to talk about the concepts of reflection, refraction, and diffraction. Then the next video will cover the concepts of interference. So we all have an idea of what reflection is, but the formal definition of reflection for any type of wave is the bouncing of a wave off an object. Now, when most people think of reflection, they think about mirrors. And that is a very good example of reflection. What mirrors do is they reflect all light waves. But in fact, everything we see has light waves bounce off of it. So when you look at yourself in a mirror, there's a source of light. Let's say it's the sun, and here's a mirror. The path of that light that you see in your eye is from the light source to you. It bounces off to the mirror and then bounces off back to you, and you are able to see that. So mirrors reflect all light, but different objects reflect different kinds of light. For instance, blue objects only reflect blue frequencies of light, right? They absorb all the other frequencies and we only get to see the blue light. And that's why we see different colors on different objects. Sound also reflects, and this is commonly called an echo, the reflection of sound. If you are near a canyon or even in like a big cavernous area, even the high school works like this if there's not a ton of people around, the sound waves that come out of your mouth will bounce off a wall and return, creating an echo effect. And even mechanical waves, such as ocean waves, can reflect. They will wash up onto the shore and then kind of wash back. Usually they're then crushed by the waves coming from the ocean still. But even those waves can be reflected. Now, this has been studied quite extensively, and there's something called the law of reflection. If you have a surface in which a wave is bouncing off of, they found out if we draw a perpendicular that's a 90-degree line down the middle, that this angle, the angle of incidence, is always equal to the angle of reflection. Basically, the angle the light comes in at, or the wave comes in at, is the angle it leaves at. So if I told you that there was a 25-degree angle of incidence, that would mean that there's a 25-degree angle of reflection. If I told you the angle from the light coming in to the light going out was 40 degrees, so let's call all of that A. If I tell you that A is 40 degrees, the light coming in to the light going out is 40 degrees, then you would be able to split that in half and tell me, well, half of that is my angle of incidence and half of that is my angle of reflection every time. And it doesn't matter what that wave is bouncing off of. It could be light bouncing off a mirror. It could be sound bouncing off a wall. That has to be true. All right, we're going to move on to refraction. Refraction is the bending of waves when they come in contact with a new medium. Remember, a medium is something the wave is traveling through. Now, I have a couple pictures here of light refraction. The first one is this prism down here, and we can see that the light comes in, bends through the prism, and then goes out. So the light enters here, bends along a different path, and then bends back when it gets back into open air. And that's because that material, that glass material, is a new medium, and thus it bends the light waves. Light waves. You can see this, you can do this at home. If you get a cup of clear water and put a pencil in it, there'll be this area right here where the pencil looks like it goes into the water isn't where it looks like it is in the water. There's a disconnect. It looks broken almost. And that's from the fact that the light going through there is refracting. The light through the air is different than the light through the water, and that creates refraction. Now, one of the classic pictures you always see with light refraction is you'll see a thing of water, and they'll have what they call the normal line, which is just perpendicular to the water. And basically, the light that comes in to that point will be bent at a different angle. And the same would be true if we started a light underneath the water, it would bend it differently when it got into air. Anytime it changes mediums, this creates refraction. Now, refraction can also occur in sound waves, but what that attributes to is a difference in volume. So the main area you see this is cold air versus warm air. Cold air allows sound to travel better because it is a different medium than warm air. There's different densities of air. And you might be able to hear things at night, such as animal calls or trains, that you normally can't hear during the day because sound travels better at night. Refraction is also the reason why waves always come up to the shoreline. So if we have a shoreline here, and let's say that our waves are coming this way, it's still going to hit this point of the beach. It's going to look like the waves are coming straight into the beach. Well, how can that happen? Basically, as the waves come this way, they're going to come into contact with the ground underneath the water, and that's going to bend the waves towards the beach. So if you stand at any point on the beach, let's say you stand here, the waves are going to be coming in the beach. Even though in the ocean they're coming this way, at the beach they're coming in this way. And that has to do with that angling. As the wave approaches, it bends in towards the coast. And so next time you're at the beach, you can look at that as well. All right, on to our last concept, diffraction. Diffraction is the bending of a wave around an object. So for light waves, there's a couple of famous examples. There's something called diffraction grating. And basically what happens in diffraction grating is white light is light composed of all the different colors. And when it strikes diffraction grating, it bends each wavelength, the red, the orange, the yellow, green, blue, indigo, and violet, at different angles. And that creates our rainbow effect. Every rainbow you see in the sky or rainbow created by a prism is diffracted white light. Now, diffraction also accounts for why when you turn a light on, that light can be visible around a corner. If we have our corner here and we have a light source here, we can see that light at this position. The light is bent around that corner. The same is true for sound. If there's a sound emanating from here, it wouldn't be blocked, it would get bent around the corner and we'd be able to hear it. This is why light and sound can be bent around corners. Now, the physical manifestation of this is in an ocean. If you have waves, let's say, and there's an island, those waves will get split when they hit the island into waves around the sides. This is also why if you had a person talking, you could hear them on either side of an object because the waves bend around that object. Now, if you still listen to radio stations, there are two types. There's AM radio stations and FM radio stations. And one of the things that's true is AM radio stations have longer wavelengths. And that allows their radio waves to handle diffraction better. They have longer ranges due to those longer wavelengths, whereas FM have shorter ranges. They are more easily interfered by buildings, trees, mountains, and so their ranges get cut down over time. All right, so let's briefly review the three. Reflection is where light bounces off of an object, or I shouldn't say light, any wave bounces off of a surface. And the angle it comes in at, the angle of incidence, is always going to be equal to the angle of reflection. That's called the law of reflection. Refraction is the wave bending as it goes through a medium. So the light wave bending as it goes through glass or water. Sound wave bending through different temperatures of air. And diffraction is the bending of a wave around an object. Now, we have enough experience with waves to know that not just one of these necessarily has to happen at a time. Every one of us has looked through a window and seen our reflection in the window, but also seen what's going on outside. So in this sense, we've seen light pass through the window, and maybe even because it's going through a different medium, that light, if the window's not real nice, that wave could be refracted, right? Or diffracted. Or sorry, it would be refracted. But there's also reflection going on because we can see our own image. So all of these can be going on simultaneously at the same time. Right? And so it's not like there's one or the other. They could all be occurring or just one of them occurring depending on the situation. When you're looking at a mirror, that's purely reflection. But when you're looking at a window and you can see your reflection and what's going on outside, you have a little bit of both. All right, next time we'll be talking about different forms of interference in waves. And so I'll see you then.